So we were trying to find the GCF of the problem, and so we decided to use the ladder method to find the GCF of 10, 25, and 30. So you would just divide by 5, and you would get 2, 5, and 6.
I'm going to stop there. Why did he choose 5? Where did he get 5 from? Where did he choose it from? Where did he get it? Dominica.
Because that's one of the common factors between them.
Thank you. Keep on going.
So, since you can't divide all three of these numbers by this same number, your GCF would be 5. But then I got curious and I was like, well, the GCF's 5. But what's the LCM of the numbers? So we went over this yesterday and we were like, you could find the LCM by multiplying, like by this L right here. And so you multiply 5 times 2 times 5 times 6.
Okay, get that in your brains. 5 times 2 is everyone?
10.
Times 5?
50.
Times 6?
300.
Nice, mental math. I love it. Okay.
And so I was like, well, 300 is a little too high. So,
because what were you thinking was the least common multiple of all these numbers, taking a look at them?
well, I thought,
Oh, do you have it in your head? Dill, you got it? What was your least common multiple?
My least common multiple, I had something else to say on this.
Oh, okay.
It was just like that. Why did he think that 300 was too high for this?
Oh, that's a really good question. Okay, go for it.
well, because I saw that these numbers were 10, 25, and 30. And I knew that, like, first of all, 10 and 25 were pretty small numbers, and so is 30 compared to, like, 300. And so I was like, well, we have 25 in there, and 30 and 10, so maybe 300 is an option. But it feels really high because times 25, it's like 12. This is 30.
What, can I stop you there for just a second? What was another strategy that he could use to find the LCM if he was like unsure of this ladder method, if it was really working? Go ahead, Matthew.
What was I going to say? Oh, yeah. What he could do is just place down the numbers. So if they like 10, 20, 30, 40, or
Got it.
25, 50, 75, 100, or 30, 60, 90, and so on.
You got it. You got that skip counting method, right? Okay, and so when you did that, you don't have to list it all out, but when you did that, what did you come up with, Will?
So I decided to do that, and I got 150 as the LCM. And so then I was like, wait, so I got 300 from these numbers, but 150 from the numbers when I just listed them out. And so I decided that I was going to figure out how to do this. So we did another LCM problem, and I was trying to figure it out.
Can you just apply what you learned from that to the numbers that we have up there?
Yeah.
Okay.
And so I was like, I showed Miss Collier, and then we found an even better strategy. So we did, should I use these?
Sure. Yeah, that's why I gave it to you. Ooh, you're reread. Ooh, what property did you just use? What? Wait, be confident. What property did you use? Raise your hand on this one so I don't hear like 1,000 different answers at the same time, so we're like totally on it. Let's go Dominica. He used the commutative property, moving from one place to another, right? Okay, so I like that he did that. Go for it.
So then I just decided, I did this problem again, and I got 5, 2, and 6.
How did you get that number? Because you divided by 5. Awesome.
And so we could make this 5 go by itself, and we're going to make another L by the 2 and the 6. And so
Freeze for a second. Can I explain this in other words, or do you see what he just did? Can you put it in other words? Matthew, what did he notice between the 2 and the 6?
He noticed that because they were even, they can both be divided by 2.
But why did he take the 5 out of it?
Oh, because
What do we know about the 5? What kind of number is that?
it's prime number.
It's a prime number, so he's kind of like the work might be like all over the place and a little, you know what I mean? The work might be a little bit all over the place, but he's taking out that 5 because he noticed a common factor between the other two numbers, and so he's going from there. Does that make sense to you? Give me a fist of 5 on that. Oh, this is so brilliant. I love it. Here we go.
And so, since these two are even, I know that it can be divided by 2. So, when you divide it by 2, you get 1 and 3. So then, wait, hold on, I think I did this wrong.
Nope, you're totally good.
So then you do 5 times 2.
Do you have another L there? Is that what you're seeing, that he kind of has another L? Could we organize our work a little better? Yes, but we have another L, and that 5 is included in part of that L. Does that make sense to you? Yeah, there's a lot of head rattles, even though I'm not moving the camera. Awesome. Keep on going with it. 5 times 2.
10
Uh-huh.
times 3 is 30.
Where'd we go wrong?
I think this 5 here.
Yep, there you go.
And so, then we multiply that by 5 then, and we would get 150, which was the LCM of these numbers.
So, your job tonight is to figure out a better way to organize all of that thinking, because we lost that 5 in there. Do you see how he followed that? We took out the 5 to begin with because it was a common factor. We took out another 5 or we took out the 2 when we noticed the other ones were in there. But somehow we got disorganized in our thinking. Give me a fist of 5 on understanding Will's strategy for finding the GCF using the ladder method when you have like something that's another common multiple in there. Oh, got some 4s, got some 5s. You might want to talk to Will about it in the future. If this doesn't work for your brain, we have lots of other strategies. Will just had an aha moment. Go ahead, Will. Add something to it.
No, never mind.
Okay. That might be another video soon, okay? So stay tuned for another video. But this is our first YouTube video that we're going to post for this. Yes, I love it. My friends, I'm really proud of your thinking. I'm proud of you for staying with Will on this one. I'm proud of you for thinking outside of the box and fixing a problem, and we'll go from there.
No one yelled at him like they did to me.
I love it. Congratulations, guys.